All right, good afternoon, everyone. I'm speaking in behalf of Autonoma. Pleasure to be here with such builders, forward-looking IT leadership. So thank you very much for having me here. At Autonoma, we like to say that we are empowering developers to create without constraints. We are a team of former Google engineers. We are backed by solid angel investors that are currently leading unicorns in Latin America. There's our Argentina flag just underneath Olea's camera. But yeah, I come down going from home. I come from Argentina, the land of Messi, Maradona, right in the south. Pleasure to be here with you guys. Currently in the Chicago University doing accelerator. That's why I'm here at Chicago. As I told you, I'm Eugenio Scafati, or Eugene in English. I'm the current CEO, and I would like to start with a fact. Something we learned in Google is that basically only 1 out of 6 projects that are in the IT domain finished on time and on budget, right? Only 1 out of 6 projects in IT finished on time and in budget. And the question here that we always make to ourselves as developers, as coders, is why are we so bad at estimating IT projects, right? So why do we usually miss the deadlines? Why do we usually meet the budgets? And the answer that we came up with at Autonoma is basically that usually coding projects are stuck with unknown unknowns, right? So all of those things that basically we don't know, that are outside of our scope of control. What happened here that we noticed while working with different corporations within Google and in our own project as well, is that basically we end up struggling most of our time with code maintenance jobs instead of actually deploying features and code for our users, instead of actually driving value for our users. And this is actually a big problem, and this is a Stripe survey that basically follows on this argument. Basically what they did, Stripe was surveyed a couple of thousands of developers out there from different corporations, from different stages, different industries. And what they came up with is basically how does a developer work looks like, right? How much time do they actually spend coding for features? How much time do they spend in meetings? How much time do they spend with code maintenance jobs? And that's what we are noticing. Basically what they say is that out of a 40-hour week, 13.5 hours a developer spends them in technical debt and 3.8 hours in bad code. That's roughly 17, 18 hours that they spent dealing with code maintenance jobs, which is around 40% of their week, right? So if we want to make some numbers, how big is this actually, and how much of a problem is it? I mean, this is another way to put it, right? So out of the 12 months of the year, only 7 months you're actually deploying features for your users, and 5 months you're actually repairing all legacy code. So I mean, if I would own a business and I see this image, this will worry me, right? So how much value are we really driving to our users if we are actually stuck with technical debt? If you want to make some numbers, so 42%, if I have a 100 developers team, and I'm paying $133 a year, which is actually the medium or the average salary for software engineers here, how much money am I losing then? That's $6 million. That's $6 million a year that a company with 100 developers is losing here in Chicago because they are spending time with code maintenance jobs. And that's just the tip of the iceberg, because actually much bigger is the opportunity cost of not having them deploying features for your actual users. So I mean, the question here is how much more value could you be adding to your users if you will be using those 90,000 hours that you are losing each year repairing old code? Why is this happening, right? So why is this happening with coding teams? This is the cycle that we think models this the best. So basically what happens? There's a feature request, right? So I have to deploy X feature into production. So leadership puts pressure into the IT teams to deploy the feature fast because there's a competitive landscape. I want to be live pretty fast. So there's pressure into the developers. What happened? Developers, there's a trade-off. Either I deploy fast, but maybe bad quality code, or I deploy slow with better quality code. So with the pressure being applied to developers, they end up deploying basically bad quality code into production. Then technical debt is generated, bugs and maintenance jobs appear, and then a new feature request suddenly lands. But you have to deal with bugs. So there's more pressure being applied to you. So even more bad quality code, and you can see how this scales over time and how it can get pretty big pretty easily. And you end up having something like this, right? So this is a meme, but I think it illustrates pretty much the reality of a lot of developer teams. That is basically that house represents the code. Basically, you have like fixes that you've done out of a hurry just to build into production. The product team basically asking for features that you can't address as a developer, but you can't explain them why. So this is actually like kind of a time bomb. And what would happen if the developer would leave the company? That's a huge knowledge gap that you leave into your coding team. So what if, that's the question we are asking us, what if we could automate all of these code maintenance jobs, right? What if we could solve them automatically? So in order to do so, first we have to understand what is code maintenance, right? So let's do a little bit of anatomy and try to understand what are the big chunks of code maintenance jobs that corporations usually have to address. The first one is fixing bugs, right? So things that are breaking in production, I have to fix them. The second one is refactors, right? So code, basically rewriting code with another practice, with another convention, just to make it more clear or maybe more descriptive or less complex. And finally, documentation, right? So documenting the code to ensure that the code understanding is proper and everyone understands what's going on in the code base. So that's what we are introducing. Autonoma is introducing the code maintenance automation built with artificial intelligence. So how does this work? Basically, the first step is you select your code base, you define your maintenance jobs, you establish your running frequency. I want to run this after every commit, after every week or whatever, and you finally run it. That's as easy as it gets. And I will show you a live demo. Okay. Let's see. You sure? Perfect. So this is our live demo. This is free, and you can access this, and you can test it later if you want. This is the URL to get into there, gitgood.autonoma.app, right? What you're seeing in screen is basically a place where you can drop code and a place where you will see the output of the code, right? So I will do an example here live for you. The first step is basically to build your own pipeline. So maybe you are a tech lead and you have certain criteria or rules that you want your developers to follow and ensure that the code that lands into production always follows these criteria. Or you are a developer that you want to automate certain tasks. So you have to put it here, right? So as I was saying, there are three main things that lands under code maintenance. The first one is debugging, the second one is refactor, and the third one is documentation. So let's try to automate one of those, right? So debugging, for example, right? So I have a couple of examples here. So if I want to make a pipeline for debugging, something that I will try to make is try to understand why bugs are landing into production, right? So what are the things that are going on with my code that makes bugs or future bugs to be debugged, basically? So one thing that I can do is start by adding docstrings and comments into my code. So basically, when a developer has to debug and understand the code, he can understand the code easier. So I just say it right, just like you can see in the screen, just expressing what I want to achieve. Add docstrings and comments. I add another node below, and I want to basically, for example, validate the inputs, right? So make input validation with the variables that are landing in my functions. I just say it like with natural language. Third one could be error catching, right? So if I have errors, I want to make sure that I'm catching those so they don't break my system. And I would add a final step that could be adding proper login messages, right? So if I'm debugging, then I want to have proper login messages telling me what's going on at each stage in the code. So I just say like that. I click here. I select a code base. I have one here that I will use. It's pretty dummy, but I mean, it will reflect how this works. So it's just a couple of functions. I'm printing those. This is Python. You click run, and I hope this doesn't break right now in production in front of you all. And what you will see, basically, is our software running and running the instructions that I just basically expressed. So adding docstrings, as you can see, the docstrings are being added. Now input validation will be added into the code base as well. As you can see, that's happening. The inputs are not validated there. They are being validated here. Then error catching. So I mean, I want this to try and not break when it doesn't work. So as you can see, that's being added here. And then login messages, right? So I want the code to print login messages at each stage of the process. And it ends, right? So as you saw, basically, this is the initial code base here, just simple, and this is the final code base, which automated certain maintenance tasks. So as you can see, I have proper docstrings. I have a try-catch logic here. I have login messages. I mean, all of that just happened automatically, and I have comments here explaining me what has just happened. And the idea behind the comments is, if you're a junior developer and you are basically learning how to code properly and much more clean, those comments will be your personalized guide. So if you basically are always making the same mistakes and instead of, for example, using camel case instead of snake case when coding in Python, and you receive the alert every time you make a commit, then you will eventually learn it. And our premise here is that would enhance the upskilling of junior developers and make them much faster to develop as senior developers. That was one example. I will make another one live. So let's say I want to make refactor, right? Which was the other code maintenance job that I was expressing. So I will start with something similar, so docstrings. So as I said, basically, refactoring is changing the code from one shape to another one, but trying to achieve the same goal at the end of the day, but maybe in a much more cleaner way, much more efficient way, optimized, without complexity. So maybe you coded and you didn't add docstrings because you're coding fast, then I will add them automatically. Another example could be, for example, more descriptive naming and make them in snake case, because I would put a Python example. The third one would be reducing the nesting. So if I have complex ifs nested, and I want to reduce those because I don't want complex code landing into production, I can do that as well. And finally, modularization, which is basically when you make big functions that accomplish a lot of tasks, and you rather want to have like one function achieving one task at a time. That's one of Uncle Bob code basically lineaments. I just express it in natural language. I click the cross. I select my pipeline. I input the code. I will copy the code. And I hit run again. And this will start running the pipeline that I just built. So I will add docstrings. Sorry, I have to scroll up. It will add docstrings, then it will reduce the nesting. So as you can see, I have horrible nested code there. It just reduced the nesting. Then I'm running modularization. So it's just one function that this will eventually split into simple atomic functions. That's the thing that I'm trying to achieve here. And it ends. Let's see how it went. So I had one function here, super nested, horrible, without docstrings. And now I have atomic functions, modularized. I have docstrings. I reduced the nesting as well. And you can go through each step and see how each transformation basically went. And of course, also read the comments as well. This is quite trivial when it's only like single file. But the idea is for you to connect it with your repository and run this after every push or every commit so as to automate it. And actually, the interesting thing is that when you connect it with your repository and you can analyze the whole code base at the same time, you can achieve much more complex things, right? So I said we were automating 3 code maintenance jobs. So those were debugging, refactoring, and documentation. So documentation, if you basically analyze the whole repository at the same time, you can achieve pretty interesting things. And I will show you a result of something that we built, which is basically, I have to share my screen again, I think. Yes, 1 second. Oh, I think sorry. Join a meeting, share screen. Here. I have to join again, sorry for that. Second, I have to move. There you are. Okay, so this is much more complex thing that you can achieve. I think it doesn't. You can see correctly, but basically what you're seeing, it's a backend application, and these are the flows of the whole application. This has been done automatically. We built this because we heard a lot of times people saying, "I'm afraid if I touch X, where it will break," and I'm not sure how the whole code is interconnected. So here you can see how the code is interconnected. So this is a backend, and as you can see, these are all endpoints, and basically you can see the whole flow. So if you click at one node, you can see this endpoint is a root that is calling this method, that this method is calling these 2 other methods right here, and this basically belong to a certain class, which belongs to a certain file. So this is being done automatically by running our pipeline behind the scenes, and we built this for a couple of clients, which basically want to understand how the system is built. And maybe you want to modernize and start with the easy ones. Maybe you want to understand the interconnections. I mean, this is solid documentation that you want to have by your side. And also, of course, written documentation of every single file. Yeah, so basically, that was the live demo. Just to close up, We're currently working with one of the top 10 biggest banks in the world, also one of the biggest telecommunications agencies from Latin America, and also a couple of software builders. I'm super happy to be here. I would like to invite you all to test the tool. If you want to play around with it, just please reach out. This was Autonoma, and we are empowering developers to create without constraints. Thank you very much.
If you're not here after the session, so anyone want to catch up, we have questions. Maybe time for one question. I want to keep it moving. Anyone has, or let's grab them.
Yeah, we would like this to run like a CI/CD. So you make a push into production. This runs. This basically sends you a couple of suggestions. You either apply them or not, and you go into production.